Here we go. Inequalities in their graph is what we're talking about today. So to begin with, let's talk about what an inequality is. Inequality is a mathematical sentence built from expressions using one or more of the symbols. You can see the names for the symbols: less than, greater than, less than or equal, greater than or equal. Basically, an inequality has an inequality symbol. Less than, greater than, less than or equal to, or greater than or equal to. Notice as they're showing you in the bottom picture, when you write an inequality, the larger parts to the open side, the smaller parts to the closed side, if you will. I talk about an inequality and think of it like an arrow. Arrow points to the smaller number. You guys may have learned in elementary school, alligator mouth. Alligator does what? Eats the bigger number. Correct. Okay. One of the things you'll have to be able to do today is to write inequalities from words, such as these keywords. Is less than, is fewer than, means the less than symbol. Notice the presence of the word less, or is, excuse me. Is less than, is fewer than, means it's an inequality. If it just says less than, you subtract. But the presence of is turns it into an inequality. Just like is means equals, is less than, is fewer than, is the inequality less than. Is greater than, is more than. What's the greater than? Is less than or equal to, is at most, is no more than. Would be less than or equal to. Is greater than or equal to, well, it's kind of apparent. Is at least, is no less than. Students in Algebra 1 do not have to retest if their test score is at least 75%. That would become the inequality. T greater than or equal to 75%. Questions so far? Okay. Take a look at some examples. Write an inequality from the sentence. In order to ride the beast at Kings Island, a person must be at least 48 inches tall. Raise your hand if you can tell me what inequality we would write for this. You get to pick your own variable. Ned, what do you think?
K is greater than 48 inches.
K is greater than 48 inches is what he says. Everybody agree? Greater than or equal to, Liz says. If I go to Kings Island, I'm exactly 48 inches tall. Can I get on the beast? Yeah. Whatever variable you wish. I used h because I'm talking height. H is greater than or equal to 48. Okay? The key word that you should see? Boom, 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 boom. At least. Okay. Take a look at number 2. An elevator has a maximum capacity of 8 people. Write me this as an inequality. Quentin. P less than or equal to 8. Exactly. Maximum means that's the most. Everything else is below that. Take a look at number 3. No more than 11 players can be on the soccer field at a time. Write me an inequality. Alexis?
P less than or equal to 11.
P less than or equal to 11. No more than means you're less than something. Okay, that's what we like to hear. All varsity soccer players must run the mile in under 8.5 minutes. Ned?
S is greater or equal to 8.5 minutes.
He says S is greater than or equal to 8.5 minutes.
Less than.
DeMonte says less than.
Oh, never mind. It is less than.
Ned now says it's less than. And you're right. Their time must be less than or equal to 8 1/2. Okay. Questions about the first of our objectives today? Okay. You also have to be able to graph the linear inequalities. Because an equation is one solution. There's one number that makes that equation true. An inequality has infinite solutions. And we show those infinite solutions on a graph. For example, all real numbers less than 2. Well, Aaron, give me a number that's less than 2. 1 is a solution, because that's less than 2. Teeny, give me another number that's less than 2. Negative 1 is a solution, because it's less than 2. So there's infinitely many solutions to these. So we show them on a graph. Notice when we view the graph of these, if you are not equal to, it's an open circle. If you are equal to, it's a closed circle. The easiest way I can think about these, as long as your variable's on the left, treat them like an arrow. Which way is the arrow pointing in number 1? X is less than 2. Which way is it pointing? Left. Which way do we shade? Left. Number 2, X is greater than negative 1. Which way are we pointing? To the right. Which way do we shade? Correct. So as long as the variable's on the left-hand side, it's pointing you to the way you shade. If you happen to be flipped around, then you flip around. It doesn't point to the way it shades, you flip the other way. The big key, remember, not equal to, open circle, equal to, closed circle. Let's try this one. Graph the inequality. X is less than or equal to 7. All these graphs go on a number line. He is. I'm sorry, there's no solicitations in my classroom. Got it. I'm tired of getting these stupid names. So let me ask this question. Children, where am I going to put my dot at? What's our variable compared to? Yes? Correct. Will that be an open or a closed circle on my 7?
Open.
Why?
It's positive.
Okay. Not open, and not because it's positive. Do we have the equal to line underneath the inequality?
Yeah.
That means it's a closed circle. Okay? So it's a closed circle on 7. Eldridge? Shaded to the left. X is less than or equal to 7. Closed circle at 7, going to the left of it, because that's where all the numbers that are less than 7 are at. Okay? I don't know if this helps or not, but if you're trying to keep this in mind, spell left for me.
L-E-F-T.
Oh, spell less then.
L-E-S-S-T-A-A.
Oh.
Less than, not less.
L-E? I remember my L-E's. Less than starts with L-E, left starts with L-E. That tells me that I'm less than, I go to the left. Number 2. Now we're going to graph X is greater than negative 6. Mr. Pettit, what do you think? Go to the right, starting from where? And is my dot on negative 6 going to be open or closed? Correct. Open dot on -6. Open dot being not filled in. Shaded to the right of -6. I believe there's a third one here. 2 is greater than or equal to x. Mr. Love. I will go left this time. Where did I put my dot at? Open or closed? Correct. Closed dot, when I say closed, that means it's filled in. It's colored, whatever you want to call it. Okay? Number 2, it's an open circle because you're not equal to -6. Okay? I like to think of it, does anybody here live on a farm? Okay? Do you have animals on your farm? What do you use to keep your animals in?
Fences.
Fences. What type of fences are they?
Electric.
Electric. Okay? I consider, and we talk more about this when we get into graphing linear inequalities when we have the whole line thing. Open circles like an electric fence. You can go right up to the boundary, but you can't touch it. Closed circle is like a wood fence, or a barbed wire fence, or a metal fence. You can go up to it, and you can touch it, because you're including that fence in. Okay? Open circle, it still keeps the boundary, but you can't touch it. Okay? Kind of like 2pi wrote about before we got that wrapper. 2pi. Can't touch these. Yeah. Wasn't that wrapper guy? Oh, Tupac. Talking about asymptotes? Can't touch them. Do 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 do. Can't touch them. Okay. All right. All right. Oh, I messed this one up, didn't I? Okay. Yep. Okay. Casey was right. I actually did this wrong on the slides. Even though I'm pointing to the right, notice my variable's not there. My variable's on the left my variable's not on the left this time, so I want to shade not the way it's pointing. I want to shade the other direction.
That is correct.
Okay. 2 is greater than or equal to x. You can also do this. When you're shading in all the numbers that make the inequality true. So look at where I shaded to the right here. Give me a number that I shaded in red. Guys, name a number that's shaded in red down here. 9. If I put 9 in, does that make this inequality true?
No.
Is 2 greater than or equal to 9?
No.
No. So I don't want to shade 9 because it doesn't make it true. 9's on the right side of the dot. I don't want to shade the numbers on the right side. I should go in the other direction. Okay? So make sure you don't follow what I put on the slides here. 3 should go the other way. Okay. And again, this is in your Google Classroom, so if you want to go back and look at these. All right. Last thing today, I believe. Write an inequality from the graph. Here comes the graph. What did I just graph here? I realize it's kind of hard to see where that dot's at. Not?
X is greater than 5.
She's correct. X is greater than 5. Circle's at 5. We shade it to the right of it. All the numbers to the right of it are greater than it. And it's not equal to because it's filled in open circle, I should say. Here comes number 2. Again, I realize this is kind of hard to see projected. Yelton.
Oh, I don't know the number. But negative 8.
Mm-hmm.
So x is less than or equal to negative 8.
X is less than or equal to negative 8. Point it to the left, shades to the left. Equal to line, because our circle's filled in. Oh, I squeezed one more in on this slide. We heard from today. Teeny.
X is greater than or equal to 0.
Correct. You are allowed to get 0 on these, guys. You can compare a number to 0. In this case, x is greater than or equal to 0. Okay. Questions on Unit 3, Day 1?